This is section 4.4, slope and rates of change. Alright, when we start thinking about slope, think about what would happen if you put a little toy car on each of these ramps. If you put it on this ramp, it would roll down not too fast. If you put it on this ramp, you can see it would roll down a little faster. And if you put a toy car on a ramp like this, it would roll down much faster. Well, what's the difference between these three triangles? Well, obviously one of them is steeper and one of them is less steep. When we talk about that in math, that's what we refer to as the slope of a line. You can find the slope of a line by looking at the ratio. Which of these three triangles has the greatest ratio of height compared to the distance that the car rolls horizontally? Well, this one only rolls 1 foot down for every 6 feet horizontally. So the slope is 1/6. This one rolls down 2 feet for every 6 feet of length, so the slope is 2/6 or 1/3. This one rolls down 2 feet for every 3 feet of length, so it has a slope of 2/3. The greatest number goes with the greatest slope. For your notes, the slope of a non-vertical line is the ratio of the vertical change, which we often call the rise, to the horizontal change, which we often call the run, between any 2 points. And the formula is written: m is equal to y2 minus y1 over x2 minus x1. y2 minus y1 is the difference between the y values. That tells you the vertical change. x2 minus x1 is the difference in the horizontal values, the horizontal change. And this is what your textbook has to say about it. If you look at it in words, we would say we're comparing the rise to the run. In symbols, we would compare the difference in the y values over the difference in the x values. And on the graph, you could physically see how far up and how far over.